Hey guys, welcome back to Quick Code. Today we're doing another quant puzzle. Today we're starting the Brainstellar series. So this is the first problem. I'll let you guys go over it. So the question basically gives us a round barrel which has a capacity of 6, among which 2 of the slots are filled with bullets and the rest of the 4 are empty. So according to the problem, what it's trying to say is if let's say the first shot was for this barrel, and the next, well, you can assume it to be either way, but I'll just assume it to be anti-clockwise. So the next one would be this one. If, let's say, this was the first shot, then the second one would be this. This is without shuffling. So you get the idea. Now, what is asked of us is the probability to hit a bullet without shuffling and with shuffling. So we have to compare these two values and see which one is greater, and that would be the case we should take. So another hint I'd like to give you guys is that to calculate the probability of any event, let's say A is our event, is actually equal to n of A upon n of S. And by n of A, I mean the number of favorable outcomes, the number of outcomes that are included in A. And by n of S, I mean the number of outcomes that are possible, the total number of outcomes. So, so coming to the solution, to calculate the first case, the number of favorable outcomes, well, we first have to understand that since it's given that during the first round, it was one of these four that were hit. So if we don't shuffle the barrel, the only four possible cases for the second time would be this one, this one, this one, and this one. So the number of total possible outcomes becomes 4, among which only this case is the case where we will be firing a bullet. So the probability becomes 1 over 4. For the second case, if we just completely shuffle the barrel, then the probability of getting any of these 6 slots is equally likely, and all of them are possible. So you basically have 2 favorable bullet slots over all of the 6 possible outcomes. So over here, our probability comes to be 0.25, and over here, it comes out to be 0.33. So as we can see, since this one is larger, we should take the second case, which means we should shuffle the barrel. Thank you.